Now speaking of sounds, let us be precise and give you some sound advice.
I'm Mike Sokol from Live Sound Co. Welcome to Live Sound Bytes, a series of single-topic videos and articles about sound system setup and operation. In this sound bite, we're going to explain how to determine the total load impedance of passive monitor wedges hooked to an amplifier. As you may be aware, power amplifiers are rated in watts at various impedances, typically 8, 4, and 2 ohms. The word impedance is just a fancy way of saying resistance, plus any extra capacitance and inductance. But we don't have to worry about those things for this lesson. The word ohm is a measure of how much resistance there is to the flow of current. So loads with higher ohms will resist more and draw less current, while lower ohms will resist less and draw more current. You'll see from the diagram that an amplifier rated for 200 watts into an 8 ohm load will be able to provide 400 watts into a 4 ohm load and close to 800 watts into a 2 ohm load. That's because the lower the impedance of the load, the more wattage the amplifier can supply. But that doesn't go on forever, since the more power an amplifier provides, the more internal heat and stresses build up in its output transistors. So we need to take speaker impedance seriously, or we'll end up with a lot of dead amplifiers. Most manufacturers recommend a minimum load impedance of 2 ohms, which draws all of the power available from an amplifier. But in the pro sound world, we want our amps to last forever. So rather than stress them to the max with 2 ohm speaker loads, we tend to keep all loads at 4 ohms and higher. This reduces heat inside the amplifier and increases the life of its output transistors, which can really take a beating at 2 ohm loads. Plus, it just sounds better since an amplifier driving a 4 ohm load will have more headroom for those tasty transients we like so much in music. How to figure out the total speaker load? Glad you asked. Let's hook up a bunch of monitor wedges and do some calculations. If each monitor cabinet is rated at 8 ohms and we hook multiple cabinets together in parallel, what's the load impedance? So here's how to calculate it. The total load impedance of 8 ohm speakers in parallel is simply the speaker impedance divided by the total number of speakers hooked together. We can see from the diagram that a single monitor wedge provides an 8 ohm load because 8 ohms divided by 1 equals 8. Likewise, 2 8 ohm cabinets will provide a 4 ohm load because 8 divided by 2 equals 4. Adding 3 monitor cabinets in parallel creates a 2.66 ohm load because 8 divided by 3 equals 2.66. And 4 monitor cabinets in parallel will produce a 2 ohm load because 8 divided by 4 equals 2. See how simple this is? If all the cabinets have the same impedance, just divide that impedance by the total number of speakers you're hooking up to find the load impedance. And remember that hooking monitor cabinets together with their in and out connections is actually putting the cabinet in parallel, not series. Since we really don't like loading power amplifiers below 4 ohms for best sound and longest life, that suggests we should hook up no more than 2 passive monitor wedges together per amplifier channel. So if we're using a stereo amplifier, that's 4 total monitor cabinets we can hook up to that amp. Again, while this same amplifier could drive up to 8 monitor cabinets in total, keeping the count down to 2 cabinets per channel, which is 4 cabinets total, improves the sound quality and reliability of the system. Nobody wants dead monitors in the middle of a performance, so loading the power amplifiers with no less than 4 ohms is the best way to keep everything happy. I've had amps running for decades simply because I don't load them below 4 ohms and clean out the air filters every year. But more on cleaning air filters later. I'm Mike Sokol, and thanks for watching Live Sound Bytes. See you next time.